We are on time instead of ahead of schedule. So my name is Brian Kinkade. I'm from Fuchs Lubricants. We are the first immersion fluid that's been recognized by OCP. So I actually moved our fluid over to the #1 spot. So just to have some fun. All right, so I'm going to talk about the journey that we took and everything that was involved. Some of it could be a little bit of the warts, but that's important because the thing is that we want to understand where these touch points are that we are currently looking at and having to deal with in the immersion community. And if you don't know me, you know this is the kind of thing I like to do. I'll go first and I'll poke fun at and poke at the problems. So we started, and we were here 3 years ago as a startup with a little booth, not even 10 by 10, and we launched our fluid. And then we didn't do anything for a little while. And then the base and the immersion requirements document got changed, and then the base fluid specification came out, and we started doing a ton of testing. And that's what's involved first. You have to just have all this data. And we had all this data, and we published it. We put it in our brochure, and we wanted to take the lead in showing all the data that's behind it that OCP was doing. And then, again, we kind of sat on it a little bit. And Rolf kind of knew about it, and then eventually says, well, why don't you just go for it? So we started it in May of this year, and we concluded it in August. The process. So the process was first filling out an Excel sheet, which you'll see pieces of, and then reviewing it with the team leads. So mostly it was Peter and Amy, who you've already seen on stage, and getting their advice and making sure everything was right, and there was a couple of things that weren't, and then getting that together and then presenting to the community. And the slides that you're going to see today is just a cosmetically improved version of what I gave to the community, and with the new template, of course. And then after we got through the community, we went to the authors of the requirements document. Everybody that's in there, they keep track of who's commenting, who's participating significantly, and it's listed on the document. And so they were all invited to review and consider what we were offering at Fuchs as whether it's meeting the requirements. And then that took a little while to get their feedback, but they gave me feedback immediately if they had questions, and I had a little bit of time to answer and provide any answers to their questions, and they had a few. And then when that was done, they had to decide yes or no. And when they were done with the yes or no, then it went further and it went through the steering committee, and then it got approved from there. So all that process took May to August. So literally August, I knew I could stand on stage and then fix my presentation. So first thing is you have minimum requirements, right? You got to meet those before you even have to think about being a fluid. And so these are the main ones: volume resistivity, flash point, auto ignition. So we're concerned about safety, dielectric performance, and the sort of corrosiveness, the good citizen nature of the fluid, right? It's not quite material compatibility, but it's the things that are going to affect material compatibility and metal compatibility. And then we get into dielectric and moisture impact, and that's how I like to think of all of our requirements. There's a group that's related to dielectric performance. And one of the things that we had was, what's the maximum moisture content for dielectric breakdown when you have 100% water saturation? Well, we couldn't get a test house to do that. We couldn't find a test house that knew how to do that exactly. And it took a long time, and so we got some information, and what it really showed was, this is a dielectric test rig, and when they added water, it just beat it and dropped right to the bottom. That's a good thing for dielectric oils. It's not a problem for our fluid, our particular fluid. They did this for a reason, but they didn't do it for our fluid. But it still was good to see that, because now we have this nice demonstrable slide I can show people once in a while. Then the next one was dielectric constant and loss tangent. This is very important, right? People are concerned about signal integrity. We're making our first line of why we're here is to cool the chips. The next line is we don't want to slow down the high-speed signaling that's needed to get all that cool data in and out of whatever are the GPUs and CPUs that have the chips. So the signaling, by default, when you add an oil, it kind of makes it like a capacitor in the signaling and slows things down, can cause delays, can cause maybe some logic 1 and 0 problems or something. This high-speed signaling guys know all that stuff, so I'm not going to try to even figure all that stuff out right now. But what they want to do is they really want to know the dielectric constant, and they also talk about needing the loss tangent as part of the problem. So they think this is all happening at all these frequencies, and there's no test requirement for that. So we ended up getting under NDA with Intel, finding that what we were doing was a resonant cavity at 7 gigahertz at room temperature, and the expert that did this said, it doesn't change that much off of that. So that's what we put in our brochure. That's what we did before we submitted. And this is what we had to go through to talk through the requirements document with Peter and Amy and all the authors and the community as to, is this really, we can't do this test, but can you still let me be a fluid? And we'll talk about how they dealt with that. But on top of that, we actually had some data that shows that it doesn't really change that much, because the problem is that it goes from 1 for air to 2 for oil. And so here's some data that just shows that it doesn't change that much. The other thing was we were asked to get data on the cooling performance from 20 to 70 C. Now, we were kind of overachievers at Fuchs. We went to 100 C. We'll probably drop some of that data if nobody asks for it anymore. But we couldn't do 25 C. We couldn't do 20 C because you have to cool the oil, and the test procedure doesn't usually set that up. So now we reported everything as 25 C. And this is all of our data. This is literally, except for the red circle, taken right out of our brochure. And, or that was the data. That was probably out of the data sheet. This is out of our brochure where we showed all the curves. And we also did the curves for figure of merit, for natural convection, and figure of merit for forced convection, which I think has been talked about before as some of the figures of merit for looking at flow and cooling. And here we're comparing, in our brochure, we're comparing our approved fluid FECC 5 to 5 synth to FECC 7. And then they wanted kinematic viscosity, which is something that isn't a normal measurement, but it's a calculated. So we offered that up. And one of the debates has been, do we need, and I think we might still be in that debate. Amy could probably comment on that if she wanted to. But do you just need endpoints and use a straight line? Is that close enough? I mean, this is really for trying to simulate, to try to come up with those calculations of when you're doing forced convection, this precision cooling, or anything. Do you need that extra information? Is the extra points on the curve worth it? And then we have vapor pressure, and they asked for it at all different temperatures. And we had only done one. We actually kind of missed that one, that we were supposed to do all those temperatures. But when you think about it, the goal of this particular spec is they're concerned about evaporative loss, but also is the oil, the dielectric fluid, going to create a headspace that maybe could be something like flammable, right? That was one of the concerns. And so we said, well, we did it at 75. That's kind of, most of the time, that's, a high temperature is the worst case scenario. So that's what we offered. And then this is it. This is the last slide of all the tests we had to do. But this is all the other things, right? And these are all fair statements. We're concerned about the toxicity. We're concerned about the oxidative stability. We've talked about that today. We're concerned about global warming and ozone depletion. And we're concerned about this STOT thing, and I didn't know what that meant. What it really means is in your SDS, it's called specific target organ toxicity, single exposure. So once again, this is more just a semantics in our requirements document. We just need to explain that for people like me who don't know what that means. But we need to get that out, right? So I was the guinea pig to just come up with all these little problems. And, but what was really interesting was we reported oxidation stability as a single point. And there's a whole report. And I didn't even know that. So it was just like the engineer, I'm in marketing and sales, so I don't, that's not what I do. But there's this whole report here. So then we went through the evaluation approach. So this was after going through this, and now we're down talking. We've talked to the community. We're talking to everybody. And Amy and Peter are dealing with these things I brought up, issues, challenges, whatever you want to call it. And, they were looking at is there anything that we really need to, work on? And what they suggested to the panel, these is to the people that originally wrote the document, that had other things in there. And so they got to all these points, and we don't need to go through them all. You've kind of heard my viewpoint of them, but this is how you simplify it and look at it. And this is closer to what we're going to be looking at as we revise from 2.1 to 3.0 and to 3.1. Which of these types of things can we deal with? And we add some things related even just to like test procedures. Some test procedures are hard to find or expensive. And maybe even we'll have some heated debates as whether they're applicable for our application. I think most of the time we did a really good job of that, but it's still good to have a nice discussion like that once in a while. So that's where everything came to. We made it through the whole thing. We got approved. We're in the marketplace. If you go there, you can find an immersion cooling fluid listed in the marketplace. We're looking at an OCP Experience Center. And our plan going forward is we're obviously going to do a lot more immersion systems. What you see on the left is our fluid working in the isotopes. They have a precision cooling chassis. It's more like a drawer, and it has one server in it. And they're almost doing like precision cooling in the sense that they're spraying the cold oil on the heat sinks. And so we've gone through all of their stuff and done 6 months of lifetime testing with a Hewlett-Packard server. So we're going to be doing more of that. We're going to be doing more AI hardware. We're going to be providing more test results. We actually like to provide the data and look at that. And I think what Samantha's done, where she's sort of anonymized her results, I'm hoping I can learn from her to offer some stuff without giving away the whole information. And then within our company, Fuchs is not just an immersion cooling company or an oil company. We have cleaners, we have system flushes, we have connector greases, so we have other things for the data center industry. And we're even looking at coolant as a subscription or like a lease. So anybody that wants to move their CapEx cost of fluid to OpEx, we're in, talk to me. So the call to action, look and do the stuff that Amy was talking about, help in taking it to 3.0. You saw the things I was dealing with. I think we can get over most of that. The fluid vendors, get certified. It's lonely up here, right? Let's get some more people up here. And, I'll still be #1 in certification, but, you guys can be up here with me. And then all the system OEMs, all the hardware vendors, talk to me. I can get you fluid. We can work on some test procedures. You got some problems. We'll help you solve them. That's like my favorite thing to do, is to solve a problem. I think that's it. Thank you to everyone, especially the team, the design engineers, the R&D engineers that helped me to get all those tests done. A lot of it was outside testing. Thank you to Peter and Amy for mentoring me through the process of, you know, in a sense, consensus, but not 100%, but how to get everything together for these requirements. And I'm looking forward to where it's going. I mean, 3.0, I can tell, is going to already be better than 2.1. I mean, just in the numbering, it's better. But I'm sure in the actual reality, it's going to be a lot better. All right, any questions? And we got lots of time, right? 5 minutes, okay.
Hey, Brian.
Hey.
So coming from the data connection side, the high-speed data connectors, and that DK value,
Yep.
that does matter for us.
Okay.
Changes of 2 to 2.1 can have a significant effect on the performance of the high-speed connectors.
Okay.
So understanding what it is across a full spectrum of the frequencies is relevant for us.
Okay.
So that's where some of these values as we get, and we're still trying to understand that.
Yep.
So if I have one fluid that's 2.1,
Yep.
another one that's at 2, and another one's at 1.9, that's 3 different connectors we got to design.
Yeah.
So
Yep.
those are things that we want to try to get consolidation in the industry among some of these fluid properties.
Yeah.
So that we don't have to design a specific connector for every one of those fluids.
Yeah. Yeah. And you're doing it at the connector level.
Yeah.
I was talking to a memory guy, and I was saying, you guys don't have active impedance adjustments in your memory modules, do you? And he says, yeah, we do. And I was like, interesting. Not, you know, still doesn't solve your problem, but at least we know they can maybe deal with it. We'll see.
Hi, for supply chain stability, if your formulation has that approval, but you need to change your base oil or the additive supplier that you work with, does that approval still stick to a formulation using the same materials from different suppliers?
So the way that we worked when we did this for Fuchs is these products are globally available. And so what that means is we know that we can get the same fluid at different countries, right, at this point, continents at this point, and that we can get that done. In terms of changing, we would have to go through some level of testing to change another supplier. But what we do as a company, so Fuchs does not extract or drill or refine. We buy from other people and mix things together. So potentially, I'm not saying we did this in this case, but potentially we can put 2 different companies' products together. And so we can have some fun that way. But we look at it from a global point of view. We want to offer right now, this is available in, we make it in Shanghai, in Germany, and in the US. So it's available in 3 places, and potentially we can make it other places if it's needed.
I just want to make a quick comment on the process. So the process that we actually have come up with to facilitate this approvals actually involves an annual check. So the products themselves will be evaluated on an annual basis, so that we'll be continually comparing them against the current version of the requirements and specifications documents. The other thing is that this is not a certification. We're not a standards body. It's a self-assessment from the vendors themselves. Any customer should be getting a C of A for every batch that they're getting to be able to make sure that the product conforms and that they understand more. The vendors themselves should be consulted. This approvals to get into the marketplace is not something that is a standard or a certification per se. It's a self-assessment. So I think it's up to the integrity of the vendor themselves to ensure that their products are of sufficient quality and that what they're reporting in the marketplace is actually reflective of the product that they're selling. Yes.
Can I just add a little more detail on that as a vendor? Because chemicals and raw materials have different availability and different production sources around the world. And different companies have different methods and processes for controlling their raw materials. So I think that's very important that you need to ask these questions to your supplier about how do they control this, and is it going to be valid if they change out raw materials in supply situations? That's definitely something that you should be doing.
Yep.
And some of the bigger companies are a little bit tighter. Some that are toll blending might not have that same kind of capability.
All right, our time is up. Who's up next?